In this sequence of videos, we're going to discuss the other trigonometric functions. So I have drawn here our xy plane with the unit circled and an angle with measurement t. And I've also marked the terminal point, that is the point at which this angle intersects the unit circle. Previously, what we've discussed is that if I have this drawing, then sine of t is the y-coordinate of my terminal point, and cosine of t is the x-coordinate of my terminal point. These are two of the trigonometric functions, and there are more. There is the cosecant function, CSC of t, cosecant. And cosecant of t is 1 divided by y. There's also the secant of t function. That's 1 divided by x. There's the tangent function. Tangent of t is y over x. And there's the cotangent function, which is x over y. Now I'm going to put an asterisk by the cosecant and the cotangent function because you notice here that I am dividing by y, and that's only going to make sense if y is not equal to 0. And let's put a double asterisk by the secant and the tangent function, and for those functions, I'm dividing by x, so x cannot be equal to 0. So let's do a brief example. Let's evaluate the new trigonometric functions, that is cosecant, secant, tangent, and cotangent for t equals pi over 4. So cosecant of pi over 4. I guess the first thing that I want to note is what is the terminal point for pi over 4. The terminal point for pi over 4 is the square root of 2 over 2, comma, root 2 over 2. Now, the way that I remember what cosecant is you'll notice that cosecant is very similar to sine. Sine of t is y, and cosecant of t is 1 over y. These secant type functions, if there's a co on it, it gets paired or is related to the original without the co. So cosecant is related to sine, and secant itself does not have a co on it. So the function that it's related to is the original function with a co. So cosecant is 1 over y, and the y-coordinate here is root 2 over 2. So this would be 1 over root 2 over 2. I think I'm going to give myself a little more room here so I can write this in a better way. So 1 divided by root 2 over 2. And now this is a fraction divided by a fraction. The numerator is 1 over 1. The denominator is root 2 over 2. And so we can multiply by the reciprocal of the denominator. And we get 2 over root 2. And whenever there's a radical in the denominator, we typically rationalize by multiplying by that radical. What this does is root 2 times root 2 in the denominator, that's just 2. And in the numerator, we get 2 root 2. You can likely convince yourself that secant of pi over 4 is going to have the exact same work because secant is 1 over the x value, and the x value is the same as the y value in this problem. So secant of pi over 4 is also 2 root 2 over 2. How about tangent? Well, tangent of pi over 4, that is root 2 over 2 divided by root 2 over 2. In general, it's the y-coordinate divided by the x-coordinate. So this coordinate divided by this coordinate. Root 2 over 2 divided by root 2 over 2. If you take something and divide by the same thing, you just get 1. And you can likely see that this is going to be the same for cotangent of pi over 4. This is also equal to 1 because cotangent is the x-coordinate over the y-coordinate, and the x and y coordinate are the same. So this shows how to evaluate some of those other trigonometric functions by knowing the terminal points for the other important angles in the first quadrant, that is pi over 6 and pi over 3, or 30 degrees and 60 degrees. You can evaluate these other trigonometric functions in the same way. And I think it's particularly important to note the tangent of these angles, these important angles in the first quadrant. I'm just going to quote the result here, and I'll let you check them as you would like. So remember, tangent of t, that's the y-coordinate over the x-coordinate. And starting at t equals 0, for t equals 0, the terminal point is 1, 0, so y over x would be simply 0. So let's make sure I'm clear about this. For t equals 0, the terminal point is 1, 0. And now if you needed to evaluate tangent of something like pi over 4, which we already did, let's do the smaller angle first, so pi over 6. I'll list the terminal point over here, that's root 3 over 2, comma 1/2. And so y, which is 1/2, divided by x, which is root 3 over 2, that's going to be equal to, let's see, 1/2 times 2 over root 3. The 2's cancel, and you get 1 over root 3. And you can rationalize the denominator by multiplying the numerator and the denominator by root 3, and you get root 3 over 3. So the important thing to note here is that tangent of pi over 6 is root 3 over 3, and that just comes from knowing that this root 3 over 2, 1/2 is the terminal point for pi over 6, and of course the definition of tangent of t. We already determined that tangent of pi over 4 is equal to 1. I'll let you, if you would like to work this out, find that the tangent of pi over 3 is root 3, and the tangent of pi over 2, which is 90 degrees, is undefined. So these 1, 2, 3, 4, 5, 6 values of tangent are important enough to list.